All right, so I think I'm recording. Let's take a look at these four problems. We want to solve each one of these equations. These are all exponential equations. You can see that the variable is an exponent. We're just going to use properties of exponents, and the fact that exponential functions are one-to-one functions is our justification in how to solve these. So on the left-hand side, on number 13, I have two terms. I need to add 14 to each side to get the term that contains my variable by itself. So by adding 14 to the right-hand side, I get 64. So now I want to rewrite the number 64 so that it has a base of 2, and 2 to the 6th power is 64. So if these numbers are the same and the bases are the same, then the exponents must be the same by that property that it's a one-to-one function. So if I subtract 4 from each side, I see that eventually that I get that x is -1. All right, so let's take a look here at number 14. I can rewrite each of these with a base of 3. 3 to the 5th power is 243. And 9 is 3 squared. So if I have a power to a power, I multiply the exponents together, and now I'll have a common base. So the numbers are the same, the bases are the same, the exponents must be the same because it's a one-to-one function. For a quadratic equation, let's get it set equal to 0. And we know that we can always solve this by completing the square of the quadratic formula, and many times we can factor it as well. If we try to factor it here, let's see what we have. The middle term is -5x, and the first term times the last term is 4x squared. So if we take a -4x times a -1x, we get the top value. But if we add these, we get the bottom value. If we put this information in the form of a table, it helps us just organize the problem to apply the distributive property to make sure that we factor it correctly. I see that I need -2 times a -1 is +2. That here I have x, 2x. So 1x times 2x is 2x squared. 1x times -1 is -1x. -2 times a +2x is -4x. And we already said the negative times negative is positive, and I get a 2 there. So that means that I can write this as 0 equals 2x minus 1 times x minus 2. And by the zero coefficient theorem, it has to be the case that either 2x minus 1 is 0 or that x minus 2 is equal to 0. Oftentimes I skip that step and just go straight to that x is 1/2 because half of 2 is 1, and 1 minus 1 is 0. Or that x is 2 because 2 minus 2 is 0. All right. I'm going to shrink both of these up, or maybe even delete them. I'll just shrink them up. All right, so let's take a look here at number 15. Now, here in number 15, I have a 1/8 over here, and I have a 2 over there. So I know that I can rewrite 8 as 2 to the 3rd power. So I have 1 over 2 to the 3rd power and x plus 2, and 2 here. Well, I'm going to have to use the fact on my properties of exponents that if you have a negative exponent, it doesn't make your answer negative. It just changes the location of that base within a fraction. That if I have 1 over x to the n, if I move that x up to the numerator, I have to change the sign of the exponent. So that's the property that I'm going to use here on the left-hand side. I'm going to rewrite this 1 over 2 to the third power to be 2 to the negative 3. And if you want, you can visualize that as over 1, because by making that exponent negative, I change the location of this base within the fraction to be from the denominator up to the numerator. And now I use another property of exponents, that a power raised to a power, you multiply the exponents. So if the numbers are the same and the bases are the same, then the exponents must be the same. So negative 3x minus 6 must represent the same number that x plus 3 does. So if I subtract x from each side, and if I add 6 to each side, if I haven't made a silly arithmetic error, I'm getting that x is negative 9 over 4. But check me on that. If you do find mistakes within the videos, let me know, because I can come in and edit them. I usually don't have to redo the entire video. All right, so this last one, let's take a look at it. On the left-hand side, I'm going to rewrite 100 with a base of 10. So I've got 10 squared is 100. On the right-hand side, I'm going to rewrite 1/10 as 10 to the negative 1. Because if I move this 10, which is currently 10 to the first power, up to the numerator, then I have to change the sign of the exponent from positive 1 to negative 1. So on the left-hand side, I have 10 raised to the 2x. On the right-hand side, I have 10 raised to the, if I have a power to a power, I multiply these exponents together. So I've got negative x squared plus 3x plus 6. So if the numbers are the same and the bases are the same, the exponents must be the same, because these exponential functions are one-to-one functions. And if I move everything to the right-hand side, I'll have a positive leading coefficient. If I subtract 3x, then I'll have minus 1x if I subtract 6. And with the leading coefficient of 1, it's much easier to factor than when it's a composite number, or a number different than 1. So I'm getting solutions of 3 and of negative 2. And with exponential equations, we don't have to worry about extraneous solutions, because the domain of an exponential function is all real numbers. If this is an incorrect solution, it's not because of the technique, it's because I've made some silly error in my algebra or in my arithmetic in this process of solving it. So hey, I hope that helps, and I'll talk to you later. Bye.